To give it back to you guys.
No, was it?
No, it was a
It
missing.
was a missing. I got my wisdom teeth out and I missed the whole thing. Then I just did it.
And there's no time left to like, just had to get done. And
And I just felt like writing.
Yeah, the one at the end.
yeah. We're going to start by setting up our OneNote for this semester. So if you guys can pull out your tablets and fire up your Microsoft Teams, we're going to get that done right away.
Yeah, or one usage of Teams a year.
Yep.
Wait, I don't want a picture of her. Did you take a picture of it?
Oh, I feel like those are just so amazing.
I didn't believe you at first.
No, that's for real.
We'll do better on the next one.
I know.
You can only do so much worse. Right?
Not a lot worse.
There's only 2 scores. You can get half a point or 0 points.
Yeah.
You know, I was
Yeah.
hoping for like a 40, and then it just got to a 2.
Yeah.
How is that possible?
All right. So once you're into Teams, go ahead and click the Teams button here on the side. You should see a bunch of tiles. One of those tiles should be 8th hour IBSL. I preloaded everybody into the course on Monday, so you should all have the tile there. If anybody's missing it, though, let me know now. Okay. Go
I
ahead.
didn't see yet.
What?
Are we supposed to be looking for it?
You should be opened up Teams. You press the little Teams thing on the side. You should have an 8th hour IBSL. Let's click it.
Oh, all teams.
Yup.
Okay, I'm in.
Okay, great. When it opens up the new panel, click on Class Notebook. So take a minute and it'll load in a OneNote notebook for you here. You stupid thing. All right. And then from the editing drop down, you're going to pick Open in Desktop. So where it says Editing, you'll do the drop down and then pick Open in Desktop. And then you're all set. And you don't have to use Teams again this semester or in this class. I know. Just the easiest way to get it shared with you.
Well, it's actually good. I probably, did we do that last semester?
Yeah. The first day.
It was a long time ago.
It was a long time ago. Anybody have issues getting their new OneNote to open up for us?
I'm just having some tablet issues.
Yeah, okay. I'm gonna move along here to the next thing. If you guys at the end of class, if you're still having issues, talk to me. I'd be happy to walk through and make sure things get all sorted out.
Wait, is this the concept test after graduation? No, that's CAD. Right. Right.
Guys, I swear.
Is there like one of those things called like FRP?
That's in history.
Oh,
So
yeah, AP does.
if you're asking, all the math questions on the IB exam are technically FRQs because there's no multiple choice. Everything is a free response question on the IB exam.
I knew it.
Okay, so they're all FRQs technically. The test is 2 days. There's 108 total points, I think, on it or something. I think like in the 60s is like a 7. Like 60% is like a 7. So like,
Actually?
yeah.
Oh, I got this.
So like, yeah, you have to write answers. That's true.
I can't leave it blank.
Can't leave it blank, and the guessing won't help you since it's free response.
Darn it.
It's like,
50% will pass.
yeah, oh yeah. 50% is like a 5 or something.
Yeah, it's a good pass.
That's a good IB score. So, and there's enough stuff on here that's pretty, just like if you can do things on your calculator well, sixes are easy. 6 is an easy score to get if you can just use your calculator well and you know what to do on your calculator. Even if you can't do any manipulation yourself, if you know what to do with your calculator, and I can do this, I can do that in my calculator, I can do that in my calculator, I can do that in my calculator. Smooth sailing. When it gets closer, we'll do some practice or whatnot and show you what the exam kind of question looks like or whatnot. But the hardest thing is usually just figuring out what to do. The how to do it is usually easy. It's what I need to do. That's the hard part. If you remember back from first semester, we had finished up all the content from chapter 12, but we didn't do the quiz or the activity or the test. We said we're going to leave that to second semester. That's what we're going to do to start here. So I'm going to do some review from chapter 12 today. I'm just going to pull some questions from the chapter 12 review. Next class, we're going to do the quiz and the activity. The class after that, we're going to do the test. Okay.
Wait, so Friday?
So Friday will be the quiz and the activity, and then the following Tuesday will be the test. But we're going to take all day today to just do questions to review. Okay? Just going to take all day today doing that. Everybody's okay? All right. So what you'll probably need, everybody will probably want their graphing calculator. If you don't have one, I have some up here on my desk. You're welcome to borrow. Yeah, no problem. We'll start by me doing most of the work on these questions, and as we kind of go on, I'll expect you guys to kind of help out a little bit more. I'm just pulling questions from the chapter 12 review. Yes.
Our quiz is on chapter 12, right?
Correct. Yes, we're doing chapter 12 right now. It was the last thing we had finished the content for, but we didn't do any of the assessments in semester 1. I would say the majority of the things you're doing in chapter 12, the calculator is going to do all of the work for you. You just have to know what to ask it to do and how to use it. So there's not a lot of work shown, so to speak. All right. So I'm just going to, what I'm looking at here, just some of the chapter 12 review problems. I've kind of picked out some of these that I think are a good smattering of things that cover the stuff we've done in chapter 12. So I'm just going to kind of start and kind of go till doing ones that I've picked out until we've either done them all or we've run out of time. Cool? Okay. So the first question reads, residents of a small town have savings which are normally distributed with a mean of 3,000 and a standard deviation of 500. Pause for right here. What is the key words you're reading in there? So it's going to tell us what we're going to be using to do this problem. Normally distributed. What's the other type of distribution we talked about in chapter 12? Start with a B. Binomial. Yeah, way to go. Somebody was paying attention. Okay. So if I want to write this symbolically, let's say that our random variable is S for savings. We'd say normally distributed. And then we write mean and standard deviation. That's kind of giving you the equivalent information in symbols that's written in words in that problem, where S is our random variable, denoting the amount of savings one of these residents of this town have. And then this is mean and standard deviation. The S is the name I've given to our random variable, denoting the amount of savings the resident in this small town has. N stands for normal, because the distribution is normal. Okay? It says then in 1A, what percentage of townspeople have savings greater than $3,200? So that's what we want, right? The probability that S, which represents the amount of savings, is greater than $3,200. Everybody's okay with that idea? So just as an aside, a visual of what we're looking for. This is like what our normal distribution looks like. The middle is the mean. And then like we would go up by a standard deviation. So what we're looking for is like 3,200 is here. We're looking for that area under the curve. Yes. Is everybody okay visually what we're looking for? So to do this, we're going to use our calculator. So go ahead and take your calculator out, power it up. We need the normal distributions. So all of our distributions live in the distributions menu. So we'll press second and then the vars button. That opens up our distributions menu. So I see three things having to do with normals. I have normal PDF, normal CDF, and inverse normal. Those are the first three options. Everybody see that? Second, and the vars button. It's underneath the down arrow. Okay. Which of these three do I want? And then why? Okay. Well, let's start with the letters PDF and CDF and ask what those stand for. PDF stands for probability density function. CDF stands for cumulative density function. Because our probability statement has an inequality in there, is that looking for S taking on a single value or many values? Many values, right? Could be 3,201, 3,202, 3,203, lots and lots and lots of them. That is cumulative because there's lots of values that I would want. Everybody okay with that? So if my normal distribution, the probability has an inequality in it, I'm going to be using the CDF. Yeah, right? Just like that. So we're going to do the CDF. Now look at the picture in green that I've drawn. Where does my shaded region begin at? What value of X? 3,200, so that's going to be my lower. Where does the shaded region end at? It goes to positive infinity. Now, can I type positive infinity into my calculator? No. So what am I going to type in instead? I'm going to type in the biggest number my calculator can hold. Well, you can do 1E99, that's fine. I'm going to do 9E99. And then I need to change the mu. What does that mu stand for? The mean. So 3,000. And then the sigma stands for standard deviation, so 500. And then I just press paste and then enter, and there's my answer. So about 34.5%. Why did I report it as a percentage rather than a decimal? The directions asked for a percentage rather than a decimal. If it didn't have the what percentage, if it just said what is the probability, could I have reported as 34.5%? Sure. Could I have also reported as 0.345? Yes. But because it asked for a percentage, I gave it as a percentage. But either answer would be fine if it just said what is the probability. Everybody okay so far? Okay. Let's do 1B. Says 2 townspeople are chosen at random. Was the probability that both of them have savings between 2,300 and 3,300? So I want the probability that both of them, townsperson 1 and townsperson 2, have the desired savings. When I have an and probability, what does that mean? Means I can multiply. So townsperson 1 needs to have savings between 2,300 and 3,300 times townsperson 2 Is everybody okay so far? Those are the exact same probability, so I'm just going to write it this way. Uh-huh. Everybody feels okay? So just calculator time. So I'll go second, and then vars to open up my distributions. Which one do I need? Nope.
CDF.
Normal CDF. I'll give you a little hint. In this class, you're never going to use normal PDF. So what is our lower on this one? 2,300. And what is our upper? 3,300. Same, still the same mean and standard deviation though. So I'll do that. And then I'll do squared. So I get 0.416. Does that feel okay?
What's the point of putting like the key T1 times T2?
Well, it's because it says there's 2 townspeople. So this is townsperson 1 and townsperson 2. So I need both of them to have savings between the desired rate or range. So townsperson 1 is here. That's their probability that they have the savings. And then townsperson 2 is there. That's the probability that they have the savings. But it's the same probability, so I just made it squared or whatever. Does that feel okay? So I used like two random variables there, the t representing a townsperson with the desired savings, and then I resolved that variable into a new the old random variable s that we knew the mean and standard deviation for. Does that make sense? Is kind of what I did symbolically.
So what was, like, does that mean anything in terms of calculations?
Not really. I'm just trying to be like careful with my notation and not abuse like what S really represents. Okay. The next one says the percentage of townspeople with a savings less than D dollars is 74.22%. Find the value of D. So if I write this as a probability statement, I'm saying this. Is everybody okay with how I've translated the sentence into that probability statement? Give you a minute to read it and look at what I've written, but it should feel pretty obvious. Okay. Notice instead of writing 74.22%, I wrote it as a decimal. Do I need to do it that way? Yes. This is a probability statement. What are probabilities always between? 0 and 1, right? So it has to be a decimal there, not a percentage. Okay? All right. So to do this, again, I'm going to use my calculator. Which one of these first three do I suppose I'm going to need? I'm going to use inverse normal because I'm given the probability and what I'm looking for is the measurement. Okay? CDF is going to go measurement to probability. Inverse is going to go from probability back to measurement. So if I click on inverse normal, it asks for this, right? Now, I think your guys' you have an additional option here. Am I correct? Type yours in. Let me know, is there an additional field? Yeah. So here's the deal. The way my calculator is programmed, inverse normal is only going to do this if the inequality is a less than or equal to. Okay? It'll only do less than or equal to's. Now, in our problem, we wrote less than. But the calculator is only going to do less than or equal to. What do I need to do to resolve that? Let's think about the picture again. If we think about the picture, it'll be pretty obvious. You don't actually need to do any multiplication. So let's say that this spot is D right here. So this is like, let me actually, oops. Ugh, come on. No, whatever, I don't care. So if I do less than D, it's like a dashed line there, right? Where it doesn't include that line, the area would. Everybody agree? If it's or equal to D, it would include that line, right? Everybody agree? What's the area of a line? Go back to geometry. It's the area for a line. Huh? No. It's 0. The area for a line is 0. A line is a one-dimensional object, right? It can't have a two-dimensional measure to it. Its area is 0. So what is that telling us then? What can we say about this normal distribution? That those two probability statements are equal. Now I want to be clear here. The probability S is less than D equals the probability S is less than or equal to D is only true for a normal distribution. Okay, when we do binomials, not true. Okay? The good news is you don't ever do inverse normals on your binomials, so it's not as big of a deal. But I want to be clear, some of you will take a real statistics course in college. I just want to make sure that we're not reinforcing wrong ideas. Okay. So if this symbol here was say a greater than, and I have to use my calculator, I have to use a complement to do it. Or if you have the tail option on your calculator, if that's a field on your inverse normal, you could just update the tail. Okay? Which tail is for less than? Left or right? Left is correct. Which tail is for greater? Right. That is correct. Does everybody feel okay on how to use the inverse normal here? So I go ahead and I typed in the area, the mean, and the standard deviation because I'm solving a less than. And I type it in, I get $3,325. Is that okay? Is this coming back at all? Probably feels pretty necessary that we're doing this though, right? Like, oof, this would have been rough coming back and doing this review on my own. All right. 2, part A says the mass W of bags of rice follow a normal distribution with mean 1,000 and standard deviation 4. So I can write that. Everybody's good? Find the probability that a bag of rice chosen at random has a mass between 990 and 1004. So that's what I'm looking for, correct? What do I use in my calculator? Normal CDF. My lower is 990. My upper is 1004. My mean is 1,000. And my standard deviation is 4. So 0.835. It says then 95% of the bags of rice have a mass less than K grams. Find the value of K. So notice this looks exactly like the setup for this one, right? Excellent. That'll be easy to deal with then. So I'll just do inverse norm, 0.95, 1,000, and then 4. So it says 1,006.57. Does that feel okay what we did there? (2C) says, for a bag of rice chosen at random, the probability that P of 1,000 minus A is less than W is less than 1,000 plus A is equal to 0.9. Find the value of A. So we have this, right? What's the problem with the way this is written? It's an inverse norm problem, right? Don't have a single inequality. I have this compound inequality thing going on. Ruh-roh, Raggy. Well, here's what I'm going to do. I'm going to draw myself a picture to kind of see what's going on. Let's use a different color. That's what we have, right? Everybody agree with the picture I've drawn? Makes sense? Okay. So, quick question. How much is that area? Olivia? Good. So that means that obviously then this area also 0.45, right? How did you know you could split it right in half, Olivia? Because the shape of a normal distribution is symmetric. So if you have stuff on equal amount on either side of the mean, you can just split it right in half because the mean is the halfway point. Everybody's okay with that? I tried my best to draw it so it looks symmetric. Sometimes your art skills fail. Okay. And then my final question to you is going to be, how much or what is that area? Let me draw it again so it's a little bit clearer. .5, great, perfect. How'd you know that, Olivia? Yeah, it's just half, right? Just half the distribution is 50%. Everybody's agree? Because we're starting from the mean, going all the way from one direction, just half. Okay. So if I put this all together then, what is that in purple? It's the probability that W is less than 1,000 plus A. Everybody agree with that? And what's the area there? 0.45 plus 0.5, 0.95. Everybody okay with this? Notice this is the exact same part as part 2B. You guys notice that? So what we know then is 1,000 plus A is equal to 1,006.57. Right? So just, this is K. So this is my K. Does that feel okay? So what's A have to be? No big deal, right? It's not that bad. You just have to remember, like, things are symmetric. You know? The mean is the center. You can split anything in half you want. It's okay? Trying to go slow and be really careful, though, yes? Trying my best, guys. All right. Number 3 says a fair coin is flipped 8 times. Calculate the probability of obtaining exactly 4 heads. So the first thing that I recognize with that is that what kind of distribution do I have here? We're flipping a fair coin. We're flipping it 8 times. How many outcomes are there for each coin flip? 2. What are the 2 outcomes? Heads or tails. Okay. Are the coin flips independent? Yes, right? One coin flip doesn't depend on the outcome of another. And do we know the probability of success? In this case, getting a head. Yes. What does that mean we have? A binomial distribution. So let's say that H is the outcome of the coin is heads. That's binomial, 8, 0.5. The numbers there are N and P, where N is the number of trials, and P is the probability of success. So the first one says the probability of getting exactly 4 heads. So the probability H is equal to 4. What's the key thing in this probability statement that's going to tell me what to do? That it's an equal sign. What does equals mean? PDF. So I'm going to go back to my VARs menu, or my distributions menu. This time I'm going to scroll all the way down to the bottom and find binomial PDF. I know to use the PDF because it's an equals sign. I'll pick that. The number of trials is 8. The probability of success is 0.5. And the number of heads is 4. So I get 0.273. Also want to point out that if you wanted this as a fraction, you could do that. All these binomial distributions should come out to be fractional numbers, because you're going to have an integer number of trials has to be, and then your probabilities are always going to be like something out of 100, right? Because it's going to be a percentage probably. So those can all come out to be fractions. Just telling you in case you're checking things in the back of the book and you can see a fractional, like no big deal. You could write as 0.273. It's not wrong. All right. Part B says exactly 3 heads. So that's that, right? I think it's going to be, will it be less or more? What do you think? I would think more as well. Oh, we were wrong. And the last one is the probability of getting 3, 4, or 5 heads. Okay. Is everybody okay with that? Now, you could do it that way with a CDF, or since this is a discrete probability distribution, you could think about it that way. Notice that we already have the answer for this, and we already have the answer for this. So all I need to do is just one more PDF and then just add them up. I think I would do it that way. Let's do that on the calculator, and I'll show you how to do it with a CDF if you would wish. So I'm going to grab my answer. There's my 0.273 plus, and then I'm going to grab that answer, the 0.21, well, I should have said 9 there, and then plus, and then distributions, binomial PDF, and this time the x is 5. So I get 711. Makes me want a Slurpee. Does that feel okay? If I wanted to do this as a CDF, let me show you the problem with that. Look at the inputs. Does it give you an upper and lower here? No. Guess what the only way this is going to do? Hi, Eva. Didn't even notice that you weren't here on my attendance list. It's bad on me, huh? I know. So I need to rewrite this as 2 less than inequalities. So I'm going to take that as everything less than or equal to 5 minus everything strictly less than 3. Everybody's okay? But the issue is that my calculator is not going to deal with a less than here. It needs to be or equal to. And we said before, for the discrete probabilities like a binomial, less than or equal to and less than do not mean the same thing. However, the integers that are less than 3 are 2, 1, and 0. So that's going to be like the same thing as just less than or equal to 2. Nora, what's up?
Can you use the bathroom?
Sure. And now I've got it into a spot where I can do this. So 8.5 and then 5. Input that in. Now do minus distributions binomial CDF 8.5 and then 2. And there I've gotten the same number. Does it matter which way you do it? No, it does not. Just presenting you both ways so you can see that it, whatever, man. What's the catch with doing it as a CDF? Yeah, and really the hardest part is like that, is remembering that less than and less than or equal to are not the same for a binomial distribution. All right, let's do some more. Okay, let's do that. That's a new kind of problem. So I'm just kind of scrolling down till I see something that's like different. Let's do these ones. Might be able to get through these 3 too. All right. So number 10 reads, a factory makes calculators. Over a long period, 2% of them are found to be faulty. A random sample of 100 calculators is tested. Write down the expected number of faulty calculators in the sample. Let's talk about the distribution first. What kind of distribution is this? It's binomial. Why do you know it's binomial immediately? There are 2 true outcomes. Either the calculator is faulty or it's not faulty. Everybody agree? There's only 2 things the thing can be. That should tell you right away it's going to be binomial. If you have 2 choices. So let's say C is whether the calculator, well, let's use F. The calculator is faulty or not, is binomial 500, 0.02. So the expected number of faulty calculators, the expectation, or even the mean, could all be the same thing here. If it's binomial, it's really easy. The formula is just n times p. Would I give you that formula on a quiz or test? Yes. So there's 4 calculators. Right? That's right, isn't it? No. 1 calculator? 1, sorry. I went the wrong way. Oh, it says 100 calculators. Well, why did I do 50 then, you bozo? I don't know. I must have read 50. Were we doing 50 in some other problem? Oh, is the next one has 50? There you go. I must have been... That's how I did it. Everybody's okay there? No big deal, right? So 10b says, find the probability that there are 3 faulty calculators. So that's just going to be the probability that f equals 3. CDF or PDF? PDF. 100 trials, 2% faulty. We need 3 faulties. So I got 0.182. So far, so good. Part C says find the probability that more than one calculator is faulty. So that's going to be the same as the probability that 2 are faulty, or 3, or 4, or 5, or 6, or 7, or 8, all the way out to 100. I don't want to do 99 PDF calculations. Yuckarooskies stab me in the eyes. We're going to do this as a CDF. What's the problem with the way that this inequality is currently written if we're going to do a CDF? There's 2 problems. It's greater than, so it's going the wrong way, and it's not or equal to. So what I'm going to do is I'm going to use the complement rule for probabilities. So I can do 1 minus, and then what is the complement? What's the opposite of greater than? No. Less than or equal to, right? Think about all the stuff that's not greater than 1. That's 1 and everything less than it. Everybody's okay with that? Can I do this on my calculator? Yes. That is easy now to do. So I'm going to start with the 1 minus, and I'll do distributions, binomial CDF, 100, 0.02, and then 1. And I get 0.597. Do you guys feel okay so far? Is this getting easier or more intuitive? Like, I see where you're going with this. That's the goal, is that this starts knocking some of the rust off. All right, let's read number 11. It says, ball bearings are used in engines in large quantities. A car manufacturer buys these bearings from a factory. They agree on the following terms. The car company chooses a sample of 50 ball bearings from the shipment. If they find more than 2 defective bearings, the shipment is rejected. It is a fact that the factory produces 4% defective bearings. What is the probability that the sample clears the deficits? Okay, first thing I'm going to do, I want to decide what kind of distribution I have here. Is it binomial or normal or something else? It is not normal. It's binomial. Why? There's 2 true outcomes. Either you accept the shipment, or either the ball bearing is defective or not, right? I'm going to do some really nasty notation. Let's use D then for defective. I hated using B for ball bearing and then B for binomial. That makes me cringe. Okay. So 11A, what is the probability the sample clears the defects? Or is clear of defects? What does that mean? The probability that D is equal to 0. It is clear of defects, meaning it has no defects. Everybody's okay with that? So we took 50 of the ball bearings in our shipment, and not a 1 is defective. Since it's an equal sign, that's a PDF. Took 50 ball bearings. The probability of getting a defective one is 4%. We want 0 defects. That's about 0.3 or 130. The next one says, what is the probability that the shipment is accepted? The question says, if they find more than 2 defective bearings, the shipment is rejected. So if it's accepted, the number of defectives should be less than or equal to 2. Do you guys agree with that? More than 2 is rejected. So 3, 4, 5, etc. is all rejects. So 2 or less should be accept. So let's do that. Since it's a less than or equal to inequality, I am all set to do a CDF. So let's do that. I like when I don't have to mess with it. That's always a relief. So that gives me 0.677. Oh my goodness. And then it says, what is the expected number of defective ball bearings in that sample? Remember, the formula for expectation for binomials is just n times p. So 2. Let's do 12 now. It says the table shows the probability distribution of a random variable x. Notice that asking the question, is this distribution binomial or normal, is stupid, right? It's clearly neither one. Everybody's okay with that? How am I supposed to solve for this k, though? What do I know about the probabilities in a probability distribution? They have to add up to 1. So I know that 2k plus 2k squared plus k squared plus k plus 2k squared plus k all has to equal 1. So if I combine like terms, I have 5k squared plus 3k, 4k is equal to 1. What type of equation do I have here to solve? Quadratic. How do I solve a quadratic equation? Must be equal to 0. So I'll subtract 1 from both sides to start. And then I would plug this into the quadratic formula. You could also factor it. It should factor. But I'm not interested in doing that because the leading coefficient isn't 1. The factoring is going to be a little bit nasty, and I'm not interested in getting nasty today. So 4 squared is 16, plus 20 is 36. The square root of 36 is 6. 4 minus 6 is negative 10. And then negative 4 plus 6 is 2. Which one of those two answers should I take? Are they both okay? Can't be negative 1. Why not? Probabilities must be a number between 0 and 1, right? So it should be 1/5. So my odds, or my probabilities then, are 2/5, 2 25ths. Yuck, that's 1 25th plus 5 25ths, 6 25ths. And then 2 25ths plus 5 25ths is 7 25ths. And I guess let's write that as 10 25ths, eh? So quick check, 10 plus 12 plus 6 plus 7 is 25. Everybody's okay there? Part B says find the expected value for x. So that's going to be, I get a 0 10 times out of 25. I get a 1 2 times out of 25. I get a 2 6 times out of 25. And I get a 3 7 times out of 25. So if I add that up, I got 35 out of 25. Now, is it okay that 35 out of 25 doesn't match any of the possible values for a random variable? Yes. Think about, on average, the American family has like 2.5 children. Obviously, that's bonkers. You can't have half a child. But it's a statistic. It's fine. Like, it's an average. That's okay. How do we feel? Better than when we started? Hopefully, yes, right? The big takeaway, hopefully, today is that the execution of these problems is very easy. The calculator will do it all. The challenging part is knowing what to do to get it into your calculator. But there's no arithmetic you need to do by hand, right? There's not even really any algebra, so to speak. I mean, we used the quadratic formula once. Oh my God. It was pretty bad. So your quiz format, things you should be able to do. Given a probability distribution, oops. Solve for the variables. What's that going to look like? That problem we just did, right? If you're looking for more practice, I think the in-class examples from 12.1 would be a good place to look if you want some extra practice there. Calculate the expected value of a probability distribution. Just like we just did, right? Also, if you want more practice, 12.1 in-class examples might be a good place to look. You should be able to write a situation as like a probability distribution. So like x is distributed as a binomial n comma p. Should be able to do that kind of thing. Know the notation. N is the number of trials. P is the probability of success. That's all you need. Okay. Calculate the expected value for a binomial distribution. That's just going to be n times p. Will I give you that formula? Yes. Calculate the standard deviation for a binomial distribution. We didn't do that at all. How do you do that? N times p times 1 minus p. Will I give you that formula? Yes. Again, if you wanted practice on these things, could you look at in-class examples from 12.2? Right? Like, there they are. And then calculate probabilities for binomial distributions using PDFs or CDFs. How do you know to tell the difference between which one to use? PDF is equals, CDF is inequality. Feel okay? And I actually think that this is I think the variance is NP times 1 minus P. So to get the standard deviation out of that, you got to square root it. Yeah, that's my bad. I can't get it's not so easy to get a square root in there. I'll do this. How's that? Okay. So that should be what to expect for the quiz. Again, I think if you did the 12.1 and 12.2 in class examples, the quiz should feel no big deal. Okay, that would be what I would practice if I'm looking for something to practice. And they're good ones to do because they have the answers all the way worked out for you, right? So we are going to put a timer on the quiz. It's 8 questions. So like take half the class period to do 8 questions, I think is probably pretty reasonable because I'd like you to do the activity the other half. That's also a pretty quick one. But you're going to have to be timing how long you can hold your breath for. Yeah. So I don't know. That's the question. How long can you?
That's a really interesting answer because it's actually quite a long time if you get past the half. That's one of the big things. What I know a lot of